Today we will do SBAC review day 6. Number 1, write an equivalent expression to the quantity 6x squared plus 2x plus 3 minus the quantity 3x squared plus 2 minus the quantity ax plus 2 using the fewest number of possible terms. So rewrite this as our 6x squared plus 2x plus 3, and then line up the like terms. So we have a negative 3x squared minus 2 and negative ax minus 2. And then combine like terms. So we have a 3x squared minus 6x minus 1. Number 2, determine whether each equation is true for all values of x. Write yes or no for each equation. So for number 1, in order for this to be true, x must be a 0. So we have 5, 6 times 0 equal to 2, 5 times 0. And this is 5 to the 0 power equal to 2 to the 0 power. So 1 equal to 1. So this is only true when x is 1. So not all values. So the answer is no. For number 2, we can rewrite 27 as 3 to the 3rd power times x equal to 3 to the 3x. And so we have the bases are the same and the exponent are the same. So this is true for all value of x. The answer is yes. For number 3, we can rewrite 49 as 7 squared times 2x equal to 7 times x. So this is 7 to the 4th power x equal to 7x. So this is not true for all x. So the answer is no. For number 4, we have 2 to the power 6x, and rewrite 64 as 8 to the 2nd power x. But 8 can be written as 2 to the 3rd power times 2x. So this is 2 to the 6x equal to 2 to the 6x. The bases are the same, the exponent are the same, so this is true for all value of x. Number 3, which equation reveals the minimum value of f of x without changing the form of the equation? So this form is called the vertex form. So then the vertex is -2, -1, and then a is a +1. So then the equation open upward, and this is the vertex, and it's the lowest point on the graph. So this will give us our minimum. Number 4, write an expression equivalent to the quantity of 4x squared plus 3y squared plus 4x minus the quantity of 2x squared plus 2y squared minus 3x. Okay, so first we need to distribute the negative into every term inside. So this gives us a negative 2x squared minus 2y squared plus 3y. And now combining like terms, so we have 4x squared minus 2x squared plus 3y squared and minus a 2y squared, a positive 4x, and a positive 3x. Combining like terms, this gives us an x squared positive y squared plus 7x. And then number 5, select the expression that is equivalent to x squared minus 81y squared. So this can be written in terms of x squared plus 9 squared y squared. X squared minus quantity of 9y, quantity squared. So a square minus a square can become x minus 9y times the quantity of x plus 9y. So the answer is A. Move on to number 6. So we can work this out two way. Write an expression equivalent to the quantity of 3 times a times b squared raised to the power of 5. So first we can combine these two. So this gives us a to the 4th power b squared raised to the 5th, and then distribute the 5 in. So give us a 4 times 5 times b 2 times 5. So this gives us a to the 20th power times b to the 10th power. Or we can do this. So we have a to the third power, ab raised b squared raised to the fifth power. So this gives us a 3 times 5, a to the fifth power, b 2 times 5. So this gives us a to the 15, a to the fifth, and b to the 10. And since these two bases are the same, we add the exponent. So a to the 20 power, b to the 10 power. So these two answers are the same. Okay, so let's move on to number 7. Select the expression that is equivalent to 25x squared minus 36. So rewrite 25 as 5x squared, and 36 is, my mistake, 6 squared. Let me erase that. So 36 is 6 squared. So where a square minus a square become 5x minus 6 times 5x plus 6. Close parentheses, so the answer is D.